Let's try another request. Oh, now it's working. All right. So with Blackfire, we execute PHP code that includes the probe that we installed that gathers data. And then the agent will send it to the Blackfire service, and then it will give us a URL here. So here you can see multiple URLs. We take this one. And that basically allows us then to completely analyze what has happened in that whatever PHP request we made. So we did a curl request to the WordPress front page now. So here we have the time, the wall time, the I/O requests. We have the CPU time. We have the peak memory. We have the network usage, we have the HTTP requests, and we have the database requests. Then we can also have a flame graph. Here we can see how the entire request happens. Every time it runs, it also gives us an overview. So we can see that the generation of the AMP version takes much longer than the generation of the non-AMP version, which does make sense because the AMP version is basically this one plus everything that is needed to be smart about transforming it into AMP. So it makes sense that it is more than the non-AMP version. However, the change is rather big, and that's what I want to work on today. So ideally, we would be able to drastically reduce this. And we have a different hotspot here. So before the apply filters, this one was the worst culprit. But now we have another one. This is a bit too small. The tag and attribute sanitizer. So immediately I get the feeling that this will be something we need to look into, because this is the get missing mandatory attributes method. And that alone takes 707 milliseconds on its own, and 1.35 seconds with all of its dependencies. So I would assume that there's something wrong there, because get missing mandatory attributes sounds like it should be one of the many details to do, not the main occupation of the AMP plugin. So I'm guessing that something is off there, and we have a good candidate for first profiling, but we'll find out more. So that's here, this bit. And we can immediately see that it is being called 420 times. So that seems reasonable. But then these 420 times, it actually calls this one 57,000 times, this one 58,000 times, and this one 58,000 times. So that lets me think that we have something that loops over too big of an area. Probably something we can drastically improve. And we can see that the tag and attribute sanitizer makes up 64% of the entire request time. And of that, the tag and attributes get missing mandatory attribute method is almost the entire time. So it is 51.63% of the total request. So there's definitely something wrong here. And the tag and attribute sanitizer is a huge part here. So this is definitely too much. This needs to be optimized. So we'll need to find out what is actually happening here. To check for missing mandatory attributes for a given node, we loop over all the attributes of the specification. But we do that for all the nodes in the document. So for all the nodes in the document, we go over all the attributes in the specification every single time. And that leads to these 60,000 requests. The thing is, how can we improve on this? Let's see. When optimizing code, you shouldn't look at what the code does first. You should first look at the logic. What is this trying to do, and does that make sense? You should try to think about the algorithm you're using first before going into details like changing a slower method for a faster method or something like that. Because most of the time these details, they make minuscule changes, but adapting the algorithm to something that's better adapted can have much more impactful changes. It can, for example, improve the execution speed by a multiple of what it is, which is not the case if you just replace, I don't know, a substring with a string pause or something like that. That is the last step you should do when you really try to get the last few drops of optimization out of it in a loop that you cannot further optimize algorithmically. But you should always look at the algorithms first. If you have multiple conditions that you check for, you should always start with the one that is either the fastest or gets the most cases done with upfront, so that, I don't know, 80% of the cases should be taken care of in a fast way and as the first check. So that the further down you go, you have the slower stuff that is only checked once in a while and not every single time in the loop. And then here, the entire thing only works if it has the mandatory attribute. So we could actually filter our optimized attributes back here and just remove everything that doesn't have the mandatory attribute. Hi, Doc, or Duke. Am I using the optimized? No, I'm actually not using it. Someone's paying attention here. This is scarily optimized, so I'm wondering now whether something might be missing. Let's see whether we actually had anything in here anymore after this run. So because if something is too good to be true, oftentimes it's just not true. So the entire work that was being done was for one mandatory rule. Could that actually be? I guess so. Charles said mandatory. All of the rest, nothing is mandatory. So these 60,000 checks that we were doing was just to verify this one attribute, whether it was true or not, whether it was present or not. That was the only thing that was needed. As you can see, once you can actually examine the internals of your code, you can reason about whether something makes sense or not and investigate it. And if you actually investigate the main bottlenecks, you get extremely good results very fast if you use a profiler. So absolutely do that. So we cannot statically store it because it does change. What we could do is store multiple versions by hashing it or something like that, but I don't know how many versions there will be. So we'll try to keep it dynamic for now. But basically still use an optimization to not have this happen within this loop. So first we get rid of everything that's not mandatory, then this loop is minimal and it has attribute stuff and so on. This only needs to happen for the mandatory stuff. Okay, so let's see whether that unbreaks our code. Yeah, that looks good. As for validation issues, yeah, that's completely unrelated. That looks good. Okay. So, is that still an optimization though? We'll have to find out now. Did I remove the error log? Yes. So let's profile again. Basically, we remove the static variable, but we're still reordering when we do what and how this affects the loops. So we try to get as much as possible out of the loops. Let's see. It's this one with this one. Yeah, that looks good. Half the time saved. 60% of the I/O saved, 50% of the memory saved. Of the CPU saved, not the memory. We have a bit more memory. Well, this has nothing to do with it. So minus 1.35 seconds of execution in this method alone. So I'd say that is quite an improvement already. Yes, that already looks much better. As you can see, the AMP portion is not more than 2/3 of the screen anymore. It's, I think, not even half anymore. So that's already great. Yeah, it's probably about half. So we have 662 milliseconds for WordPress, and the rest of the 1.28 seconds is for the AMP. So it's pretty much half. So that's already a great improvement on the execution time. And all we did was reorder this loop. Basically creating an optimized attribute spec first, and only then dealing with the for each. I wonder now whether we couldn't. So we can actually we don't need to create another array. We just need to reorder it properly. I think. So this is the important part. This needs to happen first. And now the change will probably be very straightforward. Yeah. That's all we're doing now. Okay, I will stop there for today. Well, we've been at it more than 2 hours now. Thanks everyone for joining. I hope this was interesting to you for seeing how Blackfire works and seeing how you can go about detecting bottlenecks and then fixing them and making sure that what you're fixing is actually an improvement and not making it worse. And I will probably do such optimization sessions from time to time. because I think there's not a lot of material out there to see how that works in practice and what to watch out for. So expect more like this to come in the near future.